We'll wait for a few more minutes in case few more could join. So we'll get started in a couple of minutes. I think we should get started. So thanks for joining. So this is an orientation session for the batch which is going to start on December 2nd, which would be data science and machine learning using R. So for people who vaguely know what is data science machine learning or do not know what is machine learning, this slide is for you. So machine learning is making a computer learn and take better decisions faster than human beings. That's the goal. Instead of human being taking decision, can I make a computer make a decision? So that is machine learning. How are we able to take decisions? We are able to take decisions because we learned from our experiences in the past, and we are using that learning to take some decisions. So can we teach that to a computer? Can we teach a computer this is cat and this is dog, this is red and this is blue, this is chair and this is table? Can we teach this to a computer so that in future, if a computer sees a cat, it will say it is a cat. If it sees a dog, it will say a dog. Let's say a person applies for a credit card. Can I approve or reject? If someone is doing a Google search, can I post an advertisement or not? So if a customer is visiting my store, will the customer buy or not? So all these kind of decisions and predictions, if a computer is able to do that, that is called Machine learning. A computer is able to learn and take decision. That's machine learning. Now, how is a computer able to do? Let's understand this classic Venn diagram. The predominant piece is mathematics and statistics. So there have been mathematicians and statisticians for several centuries coming up with new theorems, new algorithms, etc. And those algorithms, when put as usable software, becomes computable software, that is machine learning. Statistical and mathematics learning algorithm, when converted in a computing environment, becomes machine learning. So machine learning is an overlap of mathematics, statistics, and computer science. On this side, doing mathematics and statistics to solve some business problem is a traditional research. Using computer for doing some uh, business application, that is software development. And doing machine learning for solving business problem is data science. So data science is using machine learning to solve business problem, because machine learning community has also been there for at least 4 to 5 decades, where a lot of statistical and mathematical learning algorithms are converted as computable softwares. But those algorithms have been practically used for solving business problems only in the recent past, maybe last 10 years or so, and that is data science. So it's a hot topic, because a lot of organizations have a lot of data, and if they can use the data, and then if computers start doing decision making, you could scale up quite rapidly compared to a human based decision. Because human beings have two problems. One, we are generally biased. Our brain is more powerful than a computer, but we have emotions, we are biased, we are not consistent, we don't take the decision same way every day, and we can't scale up. We can uh, take 10 decisions in 1 hour, but a computer can take 1 million decisions in 1 hour, because a computer is scalable, but a human being is not scalable. So these two advantages which a computer has, if we can also give some intelligence which computer has, that becomes machine learning. And people have different words like artificial intelligence, etc. But finally, you are making a machine intelligent. You teach certain things for future decision. I will take a quick pause and check if all of you got the terminologies right. Prem, did you get some picture? You said you don't know what is data science, but does this give some picture?
Yeah.
Okay. Okay, with that, let's try understanding why all this excitement. Suddenly, everyone's speaking about data science, machine learning. Why is all this excitement? Because we are generating so much data. Every organization is recording so much data. We are emitting so much data. As we are speaking now, whatever I'm speaking, this go to meeting, whatever we type in the chat window, it's all data. Our mobile phones are next to us, and then the mobile phones is getting all this WhatsApp messages, Facebook feeds, etc. So the data which is being generated is so huge. We are using Google Maps, so Google keeps logging data, Uber, some food service app. So much data is being generated, and it's so much that we are generating 2.5 quintillion bytes of data every day, which is like 2.5 into 10 power 18 bytes. Huge. And whatever you have data in the world today, 90 percentage of them created in just last 2 years. So we are exponentially emitting so much data, and all these data are being logged somewhere or the other. So how can I use this? Because okay, I'm spending so much effort to have the infrastructure to log all this data, but what do we do with that data? So this is big data, which the boom happened 10 years back, where a lot of data was there and then people started logging in. Now comes the larger question. uh, I have started logging the data, but what do I do? So there was this boom of all business intelligence, big data, etc., where you generate thousands of reports, log terabytes of data. Everything is fine, but it all tells me what happened in the past. But I want a computer to go one more first step further and then uh, work for the future by itself without my help. So that's where data science motivation comes in. And and it is not just a bubble or a research topic or a proof of concept kind of a level. People are making value out of it, like retail manufacturing. It has been documented that US GDP in that industries is going to grow by 325 billion by 2020, and data analytics is expected to fuel that growth. Retail companies are using data so significantly, all the shopper car data, what people are buying, what is the pricing of competitors, demographics, so much data. And retailers, manufacturing, banking and financial services, almost all industries are using. And as such, the larger data analytics or big data umbrella, products and services is growing at 23% CAGR. You'll see all these Accentures, McKinsey's, KPMG, Boston Consulting Group, all these big consultancy companies also doing a lot of data science. And this as a service itself is growing at a 23% rate, going to hit 50 billion in US by 29. Phenomenal growth for data science. And certain other reasons for excitement were data science being used in election. Obama used data science significantly, and the first US chief data scientist was an Indian named DJ Patil, very popular figure in the data science world across the globe. He was the first chief US data scientist in White House, appointed by Obama. And even Donald Trump's win, Avinash, who is an Indian data scientist, was a key in Trump's party winning Arizona. So whenever there is an election, there is always a data science story on how data was used in campaigns, and understanding the demographics and then plan the campaign accordingly. And most important is Google. Google makes hell a lot of money using data science. So as you do a search, you see all these advertisements coming to your page, and this is all data driven. Moment you do a search, Google will know what is your age, where are you searching from, what have been your historical searches, what all have you bought, where all have you traveled, what all did you search and did not buy, what all did you click in the past. So all those data are grouped together and sent to ad tech companies, and ad tech companies will have some models in the background, and they will bid for this particular space. So Google will say, someone with this kind of a profile is searching for this term. I have 3 spaces. Whoever bids high, I will give the space. So then all the ad tech companies will start bidding for the space, and whoever the top 3 bidders will get the space. All data driven and automated. A computer doing all these things, because a human being cannot react so fast. And Google makes $50 billion per year from sponsored ads. That is 97% of the company's revenue. So the free Google Gmail, free Google Drive, everything is free in Google. But what Google actually does is it uses that to collect so much data and use that for their sponsored ads, which is $50 billion per year. And on the other side, ad tech companies also make a lot of money. Let's say Nike, Reebok, Ray-Ban, all these brands spend so much money on advertisements, and then they give to an ad tech company, I want to, my advertisement budget is $50,000, so you advertise for me in social media, Google, etc., and I am expecting a return of investment of 100%. So again, ad tech companies make a lot of money out of this. So all this hype happening, so which is fueling the data science services and products, and that's key showing up in the job growth. I did a search very recently in August. Google has something called Google Trends, where you can actually search for certain topics and then look at their trends. I did two searches: IT jobs and data science jobs. I did this two search. You can also do, after this call you can go to Google Trends page and do this search term. As such, the larger IT umbrella is declining. We all know, we are seeing the decline. Many of us are part of IT in one way or the other. That's kind of declining. The jobs are declining. Whereas the data science, an exponential growth in the last 2 years, starting from 2015, this is having a skyrocketed growth, the data science jobs. So almost all organizations are starting a data science team. You don't have enough people, and it has to be filled with existing resource. So this is the right time to get into it, because there is a significant demand. When someone gets in here, they have a prosperous career at least for the next 10 years, because this is going to grow significantly. And early movers have a lot of advantage because they get a lot of experience in that, and then they could become industry leaders in 5 to 10 years time. You can see a same trend in Indeed. I tried in LinkedIn. uh, Again, Google Trends, comparing languages like R. Everywhere you see a significant growth of data science, no doubt at all. And certain authentic reports like McKinsey told that in US there is an expectation of 140 to 180,000 data science openings by 2080. So it's a significant number. US cannot really fill that. So if someone has some skills on data science, they're going to sell like hotcake. Even India, for that matter, NASCOM reported recently that India is expected to witness a eightfold growth in data analytics. So from a $2 billion sector, it is going to become a $16 billion by 2025. A lot of outsourcing happening to India, a lot of openings in US. So in US or in India, data scientist is a hot job. You get picked up like a hot cake. I will maybe pause for a minute and check if anyone has any question.
Hey Karthik, do we need have any prerequisites for this? Do we need to have basic knowledge regarding any kind of language for this?
You don't need to, because languages like R, which are very popular in data science, are very simple to program. So someone with a uh, uh, non-programming background can actually pick it up. So from a programming standpoint, there is no real prerequisite. From the mathematical and statistics standpoint, you don't become a mathematician and statistician, you want to become a data scientist. So whatever mathematics and statistics needed uh, uh, for uh, for becoming a data science, that will be covered in the course. So as such, there is no prerequisite. The openness to learn and the willingness to accept challenge is the prerequisite. From a skill set standpoint, there is absolutely no.
Yeah, thanks.
Okay, so data science is used across uh, several functions by marketing, sales, logistics, a lot of use cases, and all these will be covered. Quite a lot of them will be covered in our course. We I will share my experiences because I am a data scientist myself for over 10 years and worked across multiple verticals. So I will be sharing my experiences. We'll be solving some use cases in the class. So we'll get in deep into all these things. And why a language like R? Predominantly, it is free and very simple to use. So you don't need to be a programmer or too strong in something to be able to do this. And 8,000 plus packages related to data analytics, data science, which you can use it. So anything you want, there is a package for it, and then you can just install and use it. Installing is quite easy. You can, it happens in a flash of second, and you don't need to take so much pain. And you have a nice IDE called RStudio, through which you can develop programs. It's a great tool because it's free, open source. It doesn't mean you have to struggle hard to program. It is quite simple to do. And an amazing ecosystem of developers. It is being maintained quite actively. So any issues, bugs, they get fixed quite often. And it is the most popular tool for data science and machine learning. So anyone can bring any language, let's say SAS or even Python for that matter. Any language you bring in, there are enough pointers to say that this is the most popular tool for data science and machine learning, because this tool or the language is exclusive for data science and machine learning and has so many libraries. And so all most of the machine learning algorithms are pre-implemented in uh, R. So it's the most popular tool. So that's why if in skill sets you will always see people asking for R for sure whenever you are applying for a data science job. And it runs in any OS. So if you write a code in Windows, you can execute it in a Linux machine, and you can again push it to a Mac system. You don't have any OS dependency. Very lightweight software. So you will be installing the R software yourself. I will be sharing the link, etc. You will actually see it to be quite a lightweight software. Doesn't occupying so much of memory space, and you don't need to be a programmer. So as Prem was asking, should I be a programmer, etc.? No, you will be like an user, and you will slowly evolve as a programmer. Since it's a very easy tool to work with, you can evolve as a programmer. Finally you will become a programmer. You will do programming in R, but you can slowly do the transition from a user to a programmer. That's how intuitive R is. It's not too new a language though. It was announced in early 90s. R originated from New Zealand. Unlike many software languages which originated in the US, R actually originated from New Zealand. And there have been a lot of releases, and the recent release is 3.4.1 in 2017. Significant number of releases and bug fixes, which means it's an actively developed software. So many developers working across the globe, across the time zones, across time, and improving the software. And what do we cover in our training? We have divided the training into two modules. One module on R programming, where someone has to get comfortable with programming in R, where we'll be covering what are the data types in R, how do you slice and dice data, how do you write control instructions, if conditions, for loop, how do you do some data processing in an optimized manner. So this is where our training will stand out, because we will say uh, how do you differ yourself from an amateur data analyst. We will show how to do some processing in an optimized manner. How do we handle different types of files? Most importantly, how do you visualize the data? A key skill for a data scientist is to be able to visualize data, and then do some storytelling on data, for which visualization is important. So this will take around a month time, close to 30 hours of classroom session, and around 50 hours of assignment, projects, etc. And once you get comfortable with R programming, we move to the next phase, which is machine learning, where we will be looking at uh, the branches of machine learning called regression, clustering, classification, dimensionality reduction, time series analysis, and text analytics. These are the branches of machine learning. We will be covering all of them, and within them we will be covering all the popular algorithms. Regression, we will be looking at linear, non-linear, multiple linear. clustering, we'll be looking at k-means. Classification, we'll be looking at all sophisticated algorithms like random forest to the most simplest algorithm like k nearest neighbor. This is an interesting topic called dimensionality reduction, where we'll be looking at principal component analysis. Time series, ARIMA, halt winters, text analytics, we'll be looking at a lot of feature extractions. So we'll go quite in deep. Again, we'll be spending 30 hours of classroom session around, and again 50 to 60 hours of assignments, projects, etc. So overall, this program could go for 2 months time with a classroom session of 50 to 60 hours, and you have to go back and work double the time. So in this, let's say we start on December 2 and we end it by end of January. By that time, you should be ready to spend at least 150 to 200 hours of effort from your side. So that's the commitment which you should have to get the best out of the course. Any questions on the training outline?
No, Karthik. Like, do we get recordings for every class, right?
Yes. Okay. So
Okay.
how the training goes? So it's a 100 percentage hands-on training. So what we'll do is it's not a theoretically oriented class. We will be actually doing stuffs in class. So what this is how a class will go. So what we'll do is I will share my screen and then say this is our studio, where I will be saying, okay, A is equal to 3, B is equal to 5, D is equal to A by B, print of D. So there is a code like this. I will ask all of you to also type out so that even only when you type you will know the issues. In case any of you have issue, you will be screen sharing, and I will be seeing what is going wrong, and every session will be recorded and all the scripts will be emailed. So whatever we develop in the class will be emailed to you at the end of class. It will be like jointly developing, because I strongly believe in hands-on session. So it is not like I will have a script and then say this is I will not say I will open a script and then say this is what it is. I will open a plain script. We all will start from a clean slate and then we will build, and by end of course you would have developed 1500 plus lines of code yourself. So you will slowly build. Every line of code will be typed by you, and so you will get a real touch. In a way, I will force you to learn. You will learn for sure. There is no way you cannot learn out of this course, because you will be forced to program in class, and the batch size will generally be small enough. So every person I will ask, hey Prem, is it working? Is hey Raju, is it working? Hey, Kiran, is it working? So there will be a one-on-one attention. So there is no way you would be missing anything as part of this, and the class will not move if someone is still fussy about something. We will still clarify and then moving. So we'll all progress as a batch, uh, and it will be 100 percentage hands-on. Recordings will be shared at the end of class, and scripts will be shared. There will be lecture notes, there will be assignments, etc. You will have enough materials, enough stuff for you to practice. So the uh, more uh, uh, efforts you are ready to put on this, I'm sure you're going to leverage a lot from this course, uh, because you will rarely find something which is so hands-on, and going to enough details, and also making sure the person on the other side learns instead of going as a mono.
Thank you, Karthik.
Okay. So the plan is we start on December 2. I will communicate the Raghu would be reaching out to you again one on one, and then we will get started. Before that, you will have the uh, download and installation instructions so that you can install. And in case you have any challenges, I doubt you will have any challenge in installing. It is such a simple tool to install. In case you have some kind of a challenge, you can always reach out to us while doing. Okay. Sivaraju, do you have any question?
Karthik, no questions are clear. No.
Okay, cool. Kiran, are you online by any chance? Okay. So as I told, the larger agenda for this meeting is to just give you a feel for how this kind of session will go, and answer any questions which I feel we have done. Raghu, I think you're online. Would you like to add anything? I think you will follow up with them after this session, Raghu.
Yeah, yes, Karthik. So that's the plan. So
Okay.
I wanted to get all of them a feel like what we are going to do and what we are going to offer. So I
Mm.
think you have walked through what we are going to do.
Okay.
So the next step, I'll be reaching out to each one.
Mm.
Maybe first initially to begin with Prem and then others.
Mm.
We'll see how. And
Okay. Cool. Is there anything else open?
And
Prem, go ahead. I think you had something.
classes would be on the weekends, right? Like the maximum classes.
I think Prem, we generally, as I told, it's a small batch. We generally go with the flexible time. I have generally found people in US okay with the weekday evening as well. So it depends on if we have only weekends, it becomes we might be a little slow, and there would be a lot of gap. Generally, people prefer at least 1 or 2 weekdays of class. I've generally found US people
Yeah.
okay with weekday evenings. This is something which we will play by ear, like my time, the students' time. As long as we are all flexible, saying, "Hey, Karthik, uh, weekday mornings are challenging. Weekdays, I generally come by 7 p.m. or 8 p.m. I can do." So on say weekends, I want to spend time with family. Maybe not after this time. So as long as you give some kind of a flexible time slot, and I have some flexibility, and we can always work it out. Being a small batch, we don't go with a too hard uh, restriction saying we do only at this time. So we will reach out to you, Prem, for your uh, uh, not preferred time. We will not ask for preferred time because we can't really converge. Then if I ask for a preferred time for everyone, we will not converge. If you have a like strong no for a particular date or time, etc., we will try avoiding that, and then come with a plan which will be suitable for everyone.
Yeah, yeah, sure.
Okay.
Sure.
Okay. If you're good, I'm done. Thanks a lot for your time. Have a great day, great evening. Bye bye.
Bye-bye.